Leo tumerudi tena Melmark Open School. Tulishawahi fika hapa mahali na tulifanya kipindi cha biology, reptiles. Leo tunafanya chemistry. Kemia kwa Kiswahili. Ila napata shida sana ili somo kulifanya kwa Kiswahili. Kwa hiyo mtaniwia radhi, Kiingereza kinaweza kikawa kingi. Na topic ambayo tutaiangalia leo ni chemical kinetics. Chemical kinetics. Lakini kabla ya kuendelea, watu wa Melmark Open School hapa wana vitu vingi wanajua kuhusu chemical kinetics. Kwa hiyo nitawauliza maswali kidogo, alafu tutaendelea. Sawa. So as I said, this is chemistry class and the topic today is chemical kinetics. I hope you have ever gone through it. Can anybody tell me what is chemical kinetics? What is chemical kinetics? Chemical kinetics. Okay, chemical kinetics. Your name first?
My name is Angela Brown. Chemical kinetic is a study of rate of chemical reaction.
Okay, she's saying chemical kinetics is the study of rates of chemical reactions. That is okay. But what are rates of reactions? Because she's saying chemical kinetics is the study of rates of chemical reactions. What is that rate of chemical reactions? Who can help us? What is the rate of chemical reaction? 1, 2. Ladies, a boy now.
My name is Flanipo Komba. Rate of chemical reaction is the amount of particle consumed or produced per unit time.
Oh, rates of reactions refers to the amount of substances that are produced. Okay, that's right. Sawa. Bado natamani kuendelea kuuliza. Hizi rates of reactions, they are affected by several factors. There are about 4 or 5 factors that affect rate of reactions. Can I have 3 factors that affect rates of chemical reactions? 3 factors. Let me go a bit far now. Factors affecting rates of reaction.
My name is Richard Deogratias Limo. 1. Temperature. And a catalyst.
Okay. So there are factors that affect reaction. Richard has given us 2. 1, temperature. 2, a catalyst. One more. This one now goes to a lady. All the way there.
Kwa majina naitwa Nasra Muhammad. One of factors affecting the rate of chemical reaction is concentration.
When we are doing the rates of chemical reactions, there are a few apparatus that we use. I have some here. One of them is called a beaker. This one is a beaker. We are going to use this to store some chemicals. There are chemicals that will be stored here. Another one is called a measuring cylinder. There are 2 of them. One is big, another one is small. We are going to use them interchangeably. We also have a conical flask. This is also very important in an experiment to demonstrate concentration is a factor that affects rate of reaction. The conical flask. We shall have a stopwatch and the chemicals as we shall see. Also, there are reagents. Here we have sodium thiosulfate and we also have hydrochloric acid, and there is water. And there is also water, because in the reaction we are going to use them all. Are we together? Yeah. So let's see the experiment, and then later I'll ask some few questions. Right? Okay. Okay, let's go for the experiment. And the issue today is on factors that affect the rates of chemical reactions. If you remember, factors that affect rates of chemical reactions fall under the topic chemical kinetics. By definition, chemical kinetics is the scientific study of rates of chemical reactions, and rates of chemical reactions refer to the amount of substances that are produced or consumed per unit time. The rates of chemical reactions are affected by several factors. Some of such factors include the concentration of the reacting species, the surface area, and the presence of the catalyst. Today we shall concentrate on the concentration of the reacting species. To go about this, we shall have a reaction between sodium thiosulfate and hydrochloric acid. From the equation, sodium thiosulfate and hydrochloric acid react to produce sulfur as deposits. We also have sulfur dioxide, water, and sodium chloride. As we shall see in the experiment, the sulfur deposits that are produced during the reaction will form a cloudy material that will diminish or make the cross perish. As the reaction proceeds, we shall record the time. Time recorded is going to be filled into this chart, which shows the experiment, shows the volume of hydrochloric acid, the volume of sodium thiosulfate, and the volume of water that is being added so that to regulate the concentration of sodium thiosulfate. Remember, as we add water, the concentration of sodium thiosulfate is going to decrease. And once the concentration decreases, the rate of reaction is going to be slow. So we shall have three experiments. The first is going to have 10 milliliters of hydrochloric acid plus 15 milliliters of sodium thiosulfate. We shall add no water, and we shall record the time. The second experiment is going to use 10 milliliters of hydrochloric acid, 10 milliliters of sodium thiosulfate, but we shall add 5 milliliters of water. The concentration is going to be a bit lower. And the last experiment is going to use 10 milliliters of hydrochloric acid, 5 milliliters of sodium thiosulfate, and 10 milliliters of water. Time recorded will tell us when and how was the reaction fast and how was it slow, depending on the concentration of sodium thiosulfate. So this practical work is going to use the following apparatus. We have a filter paper which is drawn an X. We have the conical flask and some beakers with water, sodium thiosulfate, and hydrochloric acid. We also have different measuring cylinders and a stopwatch to measure the volumes of the chemicals and time. So at the first time we are going to use 10 milliliters of hydrochloric acid, which is going to be measured by the first measuring cylinder. We pour it into the conical flask. After taking the hydrochloric acid into the conical flask, then we take 15 milliliters of sodium thiosulfate into the same conical flask and allow the stopwatch to start. Then we shall look at the conical flask to see how the X or the cross disappears. When the cross is disappeared, then we stop the stopwatch. So now the experiment goes on. You see the cloud mist is being formed and the X is disappearing slowly. At the end, we shall stop the stopwatch. The cross has disappeared, and now we record the time. After the completion of the first experiment, this second experiment is going to use 10 milliliters of hydrochloric acid and 10 milliliters of sodium thiosulfate. So we measure 10 milliliters of hydrochloric acid, we put it into the conical flask, and then we measure 10 milliliters of sodium thiosulfate. We add the 5 milliliters of water so that the reading should be 15 as usual. Then we put it into the conical flask. The reaction goes on. You see the cloud mist of the sulfur is being formed. Now the mist cloud has made the disappearance of the cross, and we stop the stopwatch. The reading now is 1 minute and 2 seconds. The last experiment is going to have more water, so we expect it to take a longer time than the previous ones. So we measure 10 milliliters of hydrogen chloride as previously. We put it into the conical flask. We again measure 5 milliliters of sodium thiosulfate into the measuring cylinder, and we add 10 milliliters of water. Then the mixture of water and sodium thiosulfate is added into the conical flask with hydrochloric acid. The reaction has started. This is going to take a little bit longer, so we have to be a bit patient. Remember, as we add water, we reduce the concentration, and therefore the rate of reaction is slowed down. That's why I said this reaction is going to take a bit longer. Time goes on, but the cross has not disappeared, but the sulfur deposits are being formed. Now the cross is disappearing. The cross has disappeared. We stop the stop clock and take the reading. So according to the experiment that you have just observed, the experiment shows that the rate of reaction is really affected by the concentration of the reacting species. By varying the concentrations of sodium thiosulfate, time also varied. So in conclusion, you see, as the concentration is high, the rate of reaction is also high. And as the concentration is lowered, the rate of reaction becomes low. In short, the higher the concentration of reacting species, the higher the rate of chemical reaction. And the lower the concentration of the reacting species, the lower the rate of reaction. So after we have seen this experiment, a lot has happened. Then I have some more questions to ask. As you saw, every time we have been adding some amount of water in the reaction process. Why do you think we are adding water? Why was water being added in the hydrochloric acid? Can someone tell me? Why do we add water? We have one here. Your name first.
My name is Blessing Emmanuel. We add water in hydrochloric acid so as to lower the concentration.
Okay, water is added so that the concentration of hydrochloric acid is lowered. Remember, in chemistry, whenever water is added, the concentration goes low because we want to see the effect of concentration. Okay, but the reaction that takes place in the beaker, is another problem. Can someone write that equation? If possible, balance it. Can someone write the equation and balance it? You want to come and write it? Good. Come and write it. So that is the chemical reaction that took place between the sodium thiosulfate and hydrochloric acid. Okay, sodium thiosulfate, hydrochloric acid. It's okay, it's okay. Please balance it if possible.
We have two sodium in reactant side. Also, we have two sodium in product side. Also, we have two chlorine in reactant side. Also, we have two chlorine in product side. Also, we have two sulfur in reactant side. Also, we have two sulfur in product side. Also, we have two hydrogen in reactant side. Also, we have two hydrogen in product side. Also, we have 3 carbon in reactant side. Also, we have 3 oxygen in reactant side. This is aqueous. Also, HCl is aqueous. Here, sodium chloride is aqueous. Also is known as table salt. This here is gas, sodium dioxide. Also, we have sulfur here. This is solid. And also we have liquid water.
Thank you. What is your good name again?
My name is Mariam Venant Mapunda.
Mariam Venant Mapunda, the future chemical processing engineer. The future chemical processing engineer. Thank you. That is the equation. I have no comment. Everything is intact. Sodium thiosulfate, hydrochloric acid, you have sodium chloride, sulfur dioxide, sulfur deposits, and water are produced. That is the reaction that was taking place. That was the reaction that was taking place. Now, in connection to this reaction, if you remember during the experiment, we had a cross that was put below the conical flask. That cross was disappearing and we stopped the clock. Why did that cross disappear? Kwa nini ile X ilipotea? Why did the cross disappear?
Kwa majina naitwa Frines Fute. X disappear due to the deposition of sulfur.
Okay. The X disappeared due to the deposition of sulfur. As you can see in the chemical equation here, one of the products that is produced is sulfur. Sulfur is the only solid. The rest are not solids. Sodium chloride is aqueous, so sulfur dioxide is gas, and this water is liquid. This solid is what goes down to the bottom of the conical flask to have the deposit that disappears the the X that we had put there. So as this reaction went on, we saw the time also took very long. The time for the cross to disappear took very long. Every time we add water, more time is consumed. From this fact, we can conclude. What conclusion do we make between the rate of this reaction and the concentration of the reactants? We must have a conclusion scientifically. Can anybody tell us what is the conclusion? Okay, conclusion. What do we conclude from the experiment?
From the experiment, we conclude that the higher the concentration, the higher the rate of the reaction, while the lower the concentration, the lower the rate of the chemical reaction. Thanks.
What is your good name again?
Blessing Emmanuel.
Blessing.
Yeah.
God bless you. So Blessing is saying the higher the concentration of the reactant, the higher the rate of reaction, and the lower the concentration of the reactants, the lower the rate of reaction. That is okay. That is all about this practical. As I said, this practical question can appear in the Form 4 national exam. Not necessarily a must, but it can be one of the questions in practical papers. Remember, when you are in Form 4, you do two papers, the theory paper and the practical paper. One of the questions can come from chemical kinetics, and you can be asked the same question. Thank you. God bless you. I wish you all the best.